Okay, we are going to start with our next speaker. Forrest is the co-founder of CodePod, and he's going to talk about CodePod, a scalable computational notebook on a hierarchical whiteboard with scoped runtime. Let's give Forrest a round of applause, please.
Thank you for your time. I'm here presenting CodePod, a scalable computational whiteboard with scoped runtime. You probably already got curious what is that logo on the top means, right? You can see it looks like a sticky note, but a sticky note can be part of a bigger sticky note. That's what CodePod is about. So let me show you. So we all love Jupyter. That's why we're all here, right? The main reason many people like us, we love Jupyter because we can quickly prototype. We can write many code short snippets, quickly try out, see what the output of it. So it's really cool. We like it. But do you all have this experience? As the notebook grows longer, your productivity slows down. And the reason is because, for example, sometimes the notebook becomes really, really long, and there are multiple other reasons. So let me go over them. So we analyzed why a longer notebook becomes harder to manage and slows down our production speed. First of all is that as the notebook gets longer, obviously we have to spend a lot of time to scroll back and forth or maybe up and down, looking for where the code you want to locate it. And the reason it's harder to locate is because the spatial proximity between code cells does not necessarily mean semantic proximity. For example, maybe here, all those red blocks, they may represent code of one functionality, and all the green blocks represent codes of another functionality, and they all intermingle together. So therefore, if you see this code block, you do not know where is the next related block is. You have to say, oh, read this block, and then read this block. So, oh, this is one next to this, actually, semantically. And another reason it's harder for us to locate the code cell we want is because of a lack of modularization. Because all those code blocks, they are just like in a one linear structure, like a skewer with a bunch of kebab on it. So it's very hard to sectionize them. Therefore, it's hard to locate them. And such spatial visualization without modularization also implies a semantic lack of modularization, which is that all those code blocks, they are on the same namespace, a global namespace. There's no separation between them. So those are the reasons why a longer Jupyter notebook is harder to manage. Therefore, CodePod come up with several solutions to keep our productivity high as the notebook becomes longer. So in order to deal with the first issue where the notebook is 1D and sometimes it's really, really long to page out, we have to do page up, page down frequently, is that we say, hey, instead of laying out the code cells vertically in a 1D linear structure, what about we allow them to do horizontally, to be spread out horizontally? Which is, this experience is like you design a slide in PowerPoint or in Google Slides where you can put text boxes anywhere on the canvas. So we say, hey, can we do that for Jupyter? Yeah, so here we go. And by doing this, you can see this huge space on the right of the notebook can be utilized. Now, to tackle the second issue is that we want the spatial proximity to be approximately equal to the semantic proximity. For example, here I define 3 functions on the top. All 3 functions, this block calls these 2 block functions. So there is a call dependency between these 3 blocks. So these are all function definitions. And when we write a Jupyter notebooks, quite often what we do is we write short snippets to test out a function we define or a class we define, right? So then I can put all the test code below this actual function definitions. So therefore, I have I have 2 dimensions of a spatial separation between code semantics. The first one is that all the function definitions are all on top, and all the test blocks are below them. And second, if you look vertically, every short test block here at the bottom corresponds to the function defined right on top of it. So therefore, by doing this, we can easily organize the code. If you want to look at all the definitions, just look at the tops. For every function you want to look at its test cases, just go down. You can have it. Now, the third thing is that we mentioned about the lack of modularization or grouping of between cells in the vertical Jupyter. So we allow you to draw scopes, which means that you can group different code cells into different groups. So here, every light blue background block means a scope. So for example, here I have a scope for these 2 blocks, for these 2 code cells. And here I have another scope for these bunch of function definitions and their test codes. Okay, so lastly, more importantly, we mentioned that this one gives us a good visual separation between the code of different functionalities. But they are still all on the same global space. Suppose I have one variable x, it means the same variable in both scopes here. So we introduced a scoped runtime. For example, here is a short demo I'll give you. You can see I have two functions defined. One is foo, the other is bar. So within these scope, which I call module cyclone, both functions are accessible because they're defined in the same scope. But outside of this scope, actually, which is what we call global scope, you can see only the function bar has a definition, right? Because it's being called and this line is being printed. But foo is not accessible, which means foo is not being exposed to code outside of its own scope. So that's what we mean by scoped runtime. So go back to this more complex or more realistic example we have earlier, is that you can see now I have two scopes, right? So this function reverse complement is being used by this function actually right here, okay? So I expose it, so therefore this line can access this function definition, reverse complement. And you can see here I define a variable x. I send the return of this function to the variable x. So this variable x is accessible within its own scope, but outside of it, it's not accessible. Now allow me to talk a little bit about our syntax here. So for any function you want to expose beyond its own scope, we just use this decorator, symbol decorator export to do that. And this decorator is language agnostic, which means that if you add this decorator on code of any languages, it will expose this function to the outside scope. All right, so these are the four changes we made to Jupyter, so such that we hope that we can keep the productivity high as the Jupyter notebook gets larger. Also, a little bit of bonus is that our code has all kinds of dependencies. For example, they can have call graph, that's one dependency. They could have execution order, or they maybe have some user-defined order dependencies, such like that. So CodePod can visualize such dependencies. So right now we are showing the function call the function call dependencies. For example, this test code relies on this function defined in this block, and this block relies on function defined here and here. Okay, and obviously you can see the typing is being imported in the global namespace, so it's being used here. And of course, we apologize for this messiness of these arrows because we are still in an early stage of developing it. We will make the more look better later. All right, and give you a little bit more showcases. So this is a showcase which I used in a class I taught online, which is about LDA, latent derichlet allocation, which is a method in natural language processing really on the topic of topic modeling. So you can see if I use a conventional Jupyter notebook to implement all the functions and demos, it's going to be a really, really lengthy notebook, and they're so long that we cannot even see what's going on over there, right? Which means that when you're actually working on this notebook, you have a lot of page up, page down to go back and forth. But if we can leverage this 2D space with a scope, okay, then we can put code blocks in an organized fashion. We can, okay, these 3 blocks, they are in one scope. These bunch of functions, they are in another scope, and we can see the order of this notebook being executed. So function definitions, the execution of the notebook. Very clear. Here's another showcase. Of course, this is a made-up case. It's not a real program. So suppose you're building a very large project. So you have this is your very high-level function. Okay, this very high-level function depends on these 3 blocks, which are top-level functions in 3 different scopes. And you can see within this scope, this function depends on the other 2 functions defined in their own sub-modules. And all those functions exposed to the upper level or to the outside, they have this, we use this green border to decorate that. And all the other code blocks, they are not exposed to the outside world. And because Jupyter, the reason we like Jupyter is because we can have code and documentation all together. So you can see within a scope, you can have the document and the code all together. So you can imagine if we export this to the document level, we can even easily have the document can have hierarchies, different sections. Like this piece of note is for section, this part of the module, this document is for this part of the module, something like that. And this is probably for the overall, like a user manual. Right. So the reason we developed the CodePod is because we ourselves and what we heard from our colleagues is that sometimes Jupyter is only useful primarily used for prototyping as a scratch pad. So when you go to production code, the programmers have to go back and forth, copying Jupyter code snippets into a conventional IDE in a file-based development environment. And if the code goes wrong in the deployment, we have to go back to Jupyter, rechange it, and then copy it again back to this conventional IDs. So such back and forth copying is very inconvenient. The reason therefore with CodePod, we hope the programmer can happily do well inside only the CodePod environment or Jupyter environment. No need to deal with the copy back and forth between this repo and the conventional IDE. And you can see why it is makes life such a task feasible, because we can have modules, right? So for example, let's look at this one. So by segregating the actual, by separating the actual function definition and their test code, when you export to production, you do not have to export these test codes. You only need to export those function definitions. And that can be easily done by analyzing the code. So therefore, such modularization allows us to export code to production code really easy. For example, if you have module, let's say I only want to export function definitions within this module, no problem. I just say export this module, forget about this module. Maybe this module only prepares the test data for functions in this module. For example, let's say they are only data loaders. They load test data while actual machine learning code is here. So that's a benefit if we can, after modularizing the code.
Can I ask a quick question?
Sure.
Is that blue box separated? And are you dragging?
Okay, yeah, good question. Well, I can give you, since we have, I can show you. So what happened is you could create a scope yourself. You can create a scope, and you can add a code in it. Yep, right. Okay, let me go back to here. Oh, sorry, I start from the beginning. Okay, here we go. All right, so, and the code actually already has hierarchies. We all know code has hierarchies. Functions call each other, right? Different files in functions in one file may be all used in by functions in many other files. However, the conventional IDE does not visualize this very well, because the conventional IDE, they look like this, right? They have a file browser and they have different text editor windows opened. Now, there are two reasons we don't like it. First of all, these functions, they may have dependencies. They have a hierarchy between them. For example, maybe we define these three functions, and this function will call these three functions. But within one file, we do not see such a hierarchy. We only see a top-down list of function definitions. Second of all, there is a separation between these, the dependency within files and the dependency within a file, right? For example, here maybe these bunch of functions are being used in these bunch of functions, but in a file-based browser, we do not see that connectivity. We only see that this file and this file, they're put under one folder. So which means the conventional IDE does not show the hierarchy of code very well. That's the reason we invented the CodePod. We want the hierarchy can be always visible to the programmer while they look at the code. So we claim that CodePod brings the benefit of Jupyter and the conventional IDE altogether. You can still do faster prototyping, which Jupyter provides you, while you still have good tools, good visualization tools to help you scale up your code, to modularize your code. And therefore, because you can modularize code, your code can go to production much faster. All right, actually this part of this slide probably shows an idea you already noticed, right? Because the code has hierarchy, and our documents actually, they also have hierarchy. But in the traditional days, when you look, for example, when you open a book, you have chapter, you have section, you have subsection, you have paragraphs, right? But books looks like that because several hundred years ago, we print books like that. Back then, there was no computer. There's no way to show something in 2D space. But now with CodePod, we can do it. So for example, here I'm showing a totally mock-up document of CodePod, right? Suppose I'm writing the document for code user manual for CodePod. I can have the title, right, of the menu, and I can have this big scope for the entire menu, and I have a preface for the menu, and I have chapter 1, chapter 2, right? And for every chapter, I can have a small section, introduction section, right? And I have the details. So therefore, CodePod has a use beyond the programmers, which means that beyond the programmers, that ordinary people can use it to keep documents, right? We can use it to take notes, for example. All right, so I talked a lot about the user experience of CodePod. Let's talk about something about what's under the hood. So we all know how Jupyter works, right? You have a web front end and talks to a Jupyter kernel in the back. So in order to allow the variable to have a scoped runtime, we add a layer in between, actually. So the variable is being rewritten to a different variable name. For example, we have two scopes, scope 1 and scope 2. They both have the variable x. Okay, we want these two x to be separate. Therefore, we rewrite the x to two different x's. For this x, I rewrite it to a different symbol, x underscore ABCD. This one to x underscore EFGH. And then therefore, these two variables are being sent to the same Jupyter kernel. That's how we are able to distinguish different variables of the same name, but under different scopes. And such mapping table, such symbol rewriting table is being maintained when you go from one scope to its parent scope to its grandparent scope all the way up. Okay, before I conclude, let me show you one picture. This is an earlier version of CodePod, actually. This is our first attempt that we decided to build a tree-based structure of Jupyter. So you can see we have a root node, and then we have this bunch of this four top-level functions, and these top-level functions are dependent on some sub-level functions, and many of them depend on some other sub-level functions. For example, these bunch of functions feed into this bunch of functions, utility functions, they feed to something like here. But we realized that actually code is not a tree. The dependency between code is not actually a tree. It's actually a DAG, because for example, we can have multiple utility functions used by multiple other functions. So it's not really a tree. So that's why we eventually go back to this, we not go back, move forward to this canvas-based, nested canvas-based visualization. So last round of applause. So please try out CodePod. You can go to our official website. It's very easy to remember, codepod.io. And we have a button. You can try our on-cloud editor, which looks like, which looks like these, but has many bugs, and we're busy fixing it. Okay, sorry. Okay. All right. And we're totally open source. We're under MIT license. So you can go to CodePod, take a look. And we really need your support. So if you can give us a star on GitHub, that'd be great. But more importantly, please give us all your feedback and thoughts, how you think about we can improve it. Okay? Hold your applause. So yeah, let me give you a really quick demo to prove that we really built this thing, okay? So all right, so that gentleman already asked, like, how do we generate the scope? So let's put on some code into the scope. So for example, let's say I define a function foo here. Let's say I return a constant 1. Okay, I execute it, and I define another function bar, and I want to return 2, for example. Okay, all right, so and then on the outside, let me try to call this function foo. Okay. Foo is not defined, right? Because it's not visible on the outside. So what I can do is I can say, hey, I want to export it. Hold on, sorry. I told you we have bugs. Okay, let me try one more time. Okay, now it works. Visually it works. Okay, hopefully it's, okay, good. All right, but if we want to call this function bar again, okay, sorry about that. But ideally, it should work like what I showed on the screen, okay? Like this, okay? So foo is exposed, bar is not exposed. Oh, yeah. Yeah, thank you. Let me try a different name. Let's call it Paris. And let's call this one Berlin. Hope I don't offend anybody from London. So let's call this function Paris. Okay, Paris is defined, and Berlin. Yeah, Berlin is not defined, okay? Right, okay, but if we add another pod here inside, okay, so then we can access, we should be able to access the function Berlin. Yeah, okay. And now I'll show you one more benefit of modularization is that you could run each scope individually, just as you run each cell individually. So for example, I think I have another demo somewhere here. Here we go. All right, so suppose I just define 3 symbol code cells. I just can click run this entire scope. Then these 3 cells will be run sequentially. Okay, see, they run sequentially. So you don't have to run the entire notebook, or you have to run individual notebook. You can group them into a scope and run only this section of code. All right.
But what does sequential mean in 2D?
Yeah, good question. So we define a simple rule of sequential. So go top down, left to right. Just that. So if you move this one to above it, then we will run this 2 first, okay? Yeah, we'll run this one first, and this one, and then this one. Yeah. And we actually we are experimenting one feature is actually you can also manually define the order of execution by drawing an arrow like this. So you can define the execution order. Yeah, and we are adding a visual feature because those arrow could mean different things. Could mean execution order, could mean call graph, could mean data dependency, all kinds of things. So we need to do a little bit of extra work to support that. Oh, and here I just show you actually one more thing. You can see if I do not want this piece of code to be within this scope anymore, I just drag it out. So when you drag it, when you move a cell in or out of a scope, this border, well, I don't have another mouse to show, but you can see this border turns red, telling you, hey, you're changing the scope of this code. So now I take this code cell outside. Yeah. So therefore, if there's no bug, if I rerun this scope, I only run these, the 1 and the 3 cell. I shouldn't run the 2 cell. Yeah, see? Only 1 and 3 got wrong. Okay, all right, a little bit of time left. Let me show you one working example. So here I'm building a bioinformatics, real working bioinformatics code. It's very simple. So this problem is called a telomere. Forget about biology. So basically what happened is you have something we call a unit string, and this unit string will repeat, and any substring belonging to the repeat of this unit string, we call it a telomere small RNA. So how do we detect this string is part of this? So here is a working example I developed. So you can see in the very inside, I implemented a function which is a very basic molecular biology thing, which is given one DNA strand. How do we compute its reverse complementary DNA strand? Okay, that's what I have. And this function, reverse complement, is being used here. Okay, by this function, and sequentially in this cell, I have 3 functions. I already talked about this briefly in the slide. So this function defines this cell is dependent, is independent. Oops. Of this cell, right? And also this one. And these are the test functions, I have them. And finally, I have this top level function, which I expose to the outside. And on the outside, I have another scope, right? This one defines a function called check candidates. And you can imagine, so check candidates and this function generate substrings of variable lengths will be used by my main function. My main function uses check candidate and generate variable strings. And of course, I have another function, beautiful print, which I put in under the global scope. So when I run my code, I could, for example, here's a test case. I run it, I could get the test result. Okay, so these are the strings. These are whether they are such called a telomere small RNAs. And of course, we inherit the visualization feature of Jupyter. So you can do plots. Of course, it's an ugly plot. Tell you a little bit tiny feature we added actually, because we realize now computer screens, they are landscape, right? So you don't want to go up and down. So therefore, you can toggle the output to the, hold on, this one should work. Yeah, you can toggle it to the right-hand side to save some space. Okay, all right, that's pretty much all what I want to say. Now, I'm ready for questions.
All right, thanks a lot, Forrest. We have a lot of time for questions. So I see one here.
Oh, sorry, I'll answer your question first. I have another thing to show. But I'll answer your question first.
So I have recently started to experiment a bit with app design, and I was thinking this could be really convenient because app code is what I use is often non-linear. But does it work with different programming languages, or is it Python?
Okay, so the question is, does it work for different programming languages? Yes, because Jupyter has kernels for so many languages, we can support them. But right now, we mainly support Python. We're going to add the support for other languages pretty soon. Yeah. Okay, before I take the second question, one more thing I want to show off is that actually probably some of you are going to ask, because this is a canvas and you have so many code cells here. What if my project is very big? Do they all become really, really tiny cells? Yes, so we have it. We have something called contextual zooming. It's very much like, for example, Google Maps. We will zoom out. For example, if you in Paris, you zoom in, you see many, many small streets, right? But when you zoom out, you only see, for example, Paris and France and Europe. So we have contextual zooming. So here is some screenshots of our contextual zooming. So you can see here we have a scope, and we have functions inside of a scope, and we have some functions on the outside. So when we zoom out, these functions inside of the scope, they will become a small icon. So, but of course, we have a very primitive way to show that. So you can see these two functions within the innermost scope became icon first, and if you further zoom, all the other things, this rich text block and this code cell, they all become icons, and these two functions at top level, they're still code. But if you further zoom out, all of them will become an icon. And note that these two functions already become invisible, become one unified icon as one scope. And if you zoom to the very top level, this scope, although it has a sub-scope, they all become one icon. So that's our contextual zooming. All right, I'll take further questions. Yeah, there's a question there. Yeah, that's a good question. So when we write programs, we want to jump to definitions. So far, we don't have this functionality, but we will add it pretty soon. Yeah.
Something that there is for Jupyter Notebook are things like Jupytext that allow you to move from a text representation to a notebook representation, so that you can edit your notebook uses just plain text with Python, and then like turn it upon it into Jupyter and see it as a notebook with the UI and the cells. Do you plan to do something like this here, where you can either export or import your code to plain Python?
Yes, we are supposed to be able to have import and export. We'll be able to export this to our JSON format, which is going to be open, or we can export it into a plain Python file. Yes, but so far, it's not really working, I can tell you. We're fixing it. Yeah, we're fixing it.
Hey, thanks for the presentation. Do you support rich output? If I wanted to render widgets, for example, how much of the widgets protocol would you support in this environment?
Widget protocol?
Yes, IPy widgets, for example.
Oh, IPy widgets. I don't think we support IPy widgets so far, but that's something we do want to add. And we know, because we know many people love it. They want to toggle a toolbar and immediately see the results. So far, I don't think we support it.
And sorry for a second question. What does it take to adapt a new kernel? So let's say I want to use Scala with this. What would it take for someone, if it doesn't work outside of the box, what would it take for someone like me to go and kind of make that compatible with this software?
Let me think about it. I don't think there are much technical challenges, right? Yeah, so so the key is under here. So you just need a parser to do this variable rewriting. If you do not want the scope, then you can use it directly, right? But if you want to use a scoped namespace, then you have to use a parser to do this variable rewriting. Yeah.
Thank you. Maybe one more question? I have a question. How does it compare to Jupyter Blockly in terms of visual programming? Do you know Jupyter Blockly?
No, I'm sorry. Broccoli, so, like the veggie broccoli?
It's a Jupyter environment for visual programming, but
well, we'll definitely look into that. Thank you for that suggestion.
Let's give Forrest another round of applause.
Thank you all.